Hello everyone, welcome back to another tutorial of Signal and Systems with MATLAB. So today we are going to discuss about the sinusoidal signals and cosine signals in MATLAB. Today I will be focusing on the basic of sinusoidal signals, how we can plot and visualize those signals in MATLAB, and additionally I will be creating subplots and hold on commands. I will show you how you can distinguish among multiple graphs, since we know that sinusoidal signal and cosine signals both have the same wave symmetry, but their values are different, especially if we talk about the sine. If the value of sine at t is equal to 0 is different, and the cosine value of cosine at t is equal to 0 is different. So today my focus will be to distinguish between these graphs on the basis of visualization. So before starting about the tutorial, you can see the overview or the front look of my MATLAB. I am using MATLAB 2021. So here you can see that I was practicing few examples in MATLAB. So I have my output history in command window, and I have few stored variables in the workspace. So first thing first, let me clear my command window and clear all the variables. So CLC command is used for the command window and clear all is used for the workspace. Additionally, I have already discussed that close all window is a good practice to include in your codes, because it will help you to close all the existing MATLAB windows. So today, as we are going to discuss about the continuous time sinusoidal signals and cosine signals, so let me initialize time. So in my previous examples, you should have observed that I take time from -10 to 10, and those are 21 samples. But when we talk about the sinusoidal signals and cosine signals, their values change on every bit of the time. So it is a good practice to take your time stamp very smaller and have some smaller steps in it. So let me show you. First of all, I will take my previous example of time that we have been taking. So let me initialize time from -10 to 10 with the step size of 1. I will also discuss what is the effect of this step size here. So just let us run it as per our previous practice, and signal is equal to the command for developing a sinusoidal signal is sine. So basically, when we talk about the sinusoidal signals, the property of sinusoidal signal is sine omega t, and omega stands for the 2ft, and basically that is the angular frequency. So basically I have mistakenly talk about the 2ft. Angular frequency is 2 pi f. So for that, I will be taking it as 2. Steric is used for the multiplication. In MATLAB we use pi for um, the pi symbol. Okay, and then let me define its frequency is equal to 1. You can change it as per your choice, but I want to keep it as simple as possible. And the variable time. So just generically let me plot a basic sinusoidal signal, time comma signal. So here you will see why I was talking about that you have to keep your time stamping smaller, and the step in that time should be a very smaller, to get more concise pattern of the sinusoidal signal. So let me run it. Here you will see its output. So you can see from -10 to 10, it is giving us, it is not giving us any pattern in it. It is just decreasing its values, and if we see about the values on the y-axis, those are very very smaller values. So to make it more appropriate, let me choose the step size a little bit smaller, but I will not disturb the range of my signal. So let me choose 0.001. So let's see what it will do. Before visualizing this graph, let me talk about it. What it will do, it will plot that value on every 0.01 second, and it will cost us computational time. Our signal will take time to get plotted, but when it will be in front of us, you will see that we cannot visualize anything. In our last practice, we took the timestamp of 1, and now we are taking the timestamp of 0.001. So when the timestamp was step size was 1, it just shown us a straight line. But now when I will decrease its time to 0.001, you will see that it will cover all the plot area. So let me run this code. It will take some time. So now here it has covered all the area of our plot. So from this we cannot visualize that what is the value of sinusoidal signal at 0, what is the value, its value on point 1. So for that purpose, let me reduce my timestamp and let us revisualize it, what it will uh, provide us, what it will show us. So here you can see that from this we have just simply made a very good and perfect sinusoidal signal. And if I place my cursor here, you can see that at this certain point we have the value of x 0.002 and y 0.001. So which means that at this very specific point, its value is sine of 0 is equal to 0. So we have visualized it here. So to make it more appropriate, or to compare this signal with our cosine signal, so let me define another variable, and in that variable I will make a cosine signal. So I am initializing another variable called other. For cosine signal, the command is cos and 2 steric pi steric 1 steric time. So what I will do, I will plot this time comma other. So now here you can see that when I run this code, it will show me only one plot. But in my code, I have written two lines for plot. So in this tutorial, I will also discuss about the properties of plotting and charts handling, how you can handle charts and how you can visualize those in such cases. So let me run it. So once I have run it, now you can see that it has shown me only one figure, but it is not showing me the graph of sinusoidal signal. It's a different behavior. So for cos, you can see that at 0 its value is 1. Okay, the graph output is fine, but I want to show two graphs. I want to compare these graphs, but this is not allowing me to plot the sinusoidal signal as well. So in my previous tutorial, I used a practice to write figure command, which opened a new figure window. So let me include it here. So as in MATLAB, we know that the codes are run line by line. So it will start running from this point, then it will clear variable, then it will close all the existing windows, then it will run by time, then signal, then plot. Once it has plotted the sinusoidal signal, after that it will open another figure. And in that very specific figure, it will plot our cos signal. So let me run it. Now we will have two figures, figure 1 and figure 2. Figure 1 will based on the sinusoidal signal and figure 2 is based on the cos signal. So at this point, you can see that it has two figures. But when I want to include it in my reports, I want to include such graphs in my research articles or anything I want to do with this, it is very inappropriate to have two different figures for the very same kind of for the very same kind of graphs. And also the issue with this approach is I cannot compare these files. I cannot conclude anything by just observing at that graph. So let me make some modifications in my graph. So to achieve this, first of all, I will use the approach of subplot, then I will take it to the advanced level. So for the subplot, the purpose of subplot it will show both of the graphs in only one figure. So for subplot, we use the command subplot, and since I have only two figures in it which I want to include in one, so the main feature of subplot is, since the MATLAB is based on the matrix laboratory, so what it will do, it's first attribute is the number of rows, second attribute is the number of columns, and uh, third one is for position. So here you can see that m comma n comma p. M stands for rows, n for columns, p stands for position. So I want to have two rows and one column. If you remember, if you can imagine the matrices, so you can see that a matrix of 2 cross 1 has two rows and one column, and I want to place sinusoidal signal on the first position. Additionally, I will make its title as well. So for the title, I am writing sine wave, and I want to label it axis, its axis, and on the x-axis I want to write time, and on y label I simply want to write its amplitude. So okay, fine. So let me do the same practice for the cos signal as well. Okay, here I will write cos, and I have to define the subplot here as well. Subplot now 2 comma 1 comma 2 position. So on the second position I have placed it as cos. So I have places here some commas. The same command work with or without commas in a same manner, so you don't need to worry about. That's why I have written here intentionally commas here, and I have removed those here, so you can also know that there is no difference in both of these approaches. So let me run it. Okay, fine. Now you can see that uh, I have an chart available in my front, so I can visualize that this signal is for sine wave, this is for cos wave. So there is I do not have to look on the two other separate windows. But still, let's suppose I want to observe that what is the value of sine at sine of 0 and what is the value of cos of 0. What are the points where these two are overlapping, and what are additional. Still I cannot obtain as much as possible information from these graphs. So for that purpose we use another approach, which is the hold on approach. So to make difference between these two approaches, let me allow you let me allow to initialize another figure. So I will practice the whole effect of hold on command in another figure. So for hold on, you have to write hold on and hold off, and in these hold off and hold on commands you just simply have to put plot time comma sine and plot time comma uh sorry, I have put the wrong variable name here. This is the signal name, variable is signal, and for cos purpose we have the signal name other. So time comma other. So now let me show you what is the difference between these two types of graphs. Okay, yes, here you can see that in the first half of the code, which was this, the code length was excessive. I have to write separate axis labels for both images. I have to write two lines for the subplot command, but when I use the command of hold on, what it did, it just simply uh, kept on holding the previous output and mapped the newer one on that okay now. And also by default it has changed its color as well. But from this there is a problem. We cannot see what is the waveline for sine wave and what is the waveline for cos wave. So for that purpose, let me introduce you with the concept of legends. Okay, fine. For legend, so we just simply need to go to the help section and write the legend and click on it. MATLAB help is a very excessive library for you, where you can practice as many as possible features of MATLAB. So when I click on the its context, I can reroute to the example section, and I have just simply copied that command. Now I'm going to place it here at this place, and also I want to include the other properties of graph as well. So here I am going to write about a comparison of sine and, okay, sorry, comparison of sine and cosine functions. Cosine functions. Okay, fine. And here I am going to write sine, and here I'm going to write cos. So you should be careful while referring the legend, because its sequence should be same as you have defined your signals here. Here I have stored the signal sine before the other signal, so that's why I have written it here. So let me run it. Now you will see a very advanced feature of it. Okay, it is taking some time. Okay, fine. Now you can see what is the difference. So the subplot approach is better, but the hold on approach is more appropriate for our cases. So that's why I showed you starting from a very basic signal, then I moved to subplot signal, and then at the end I concluded all of this with the help of hold on and hold off command. So I holded those results. So from here you can simply tell that at time when the time was 0, cos of 0 was 1, and when it was the value of sine, so for the case of sine of 0 is 0. So you can simply talk about it and use it for your further programmings. So thank you so much for watching my tutorial. If you have liked this tutorial, you can simply subscribe to my YouTube channel, and you can leave comments if you want to know about the know about a very specific comment, because I am trying to cover complete MATLAB series. With respect to the signal and systems, definitely I will talk about the Fourier transforms, Fourier series, Z transforms, and the sampling in the signals with MATLAB. And after that, I will move to the signal processing uh, concepts. But that will take time, since I want to make a very basic course on the signal and systems with MATLAB. For that purpose, I am uploading my videos on the daily basis. So without taking your more time, just simply like, subscribe, and comment. Thank you so much for watching.